Okay, so now we're going to take Pascal's triangle that we learned a couple of videos ago, and we're going to apply that to a carnival game, and we're going to use that to see how many prizes we need to buy. Because pretend like we're setting up a carnival for our school and we're trying to do like a fundraising thing. So we want to figure out how many prizes we need, and we're going to use Pascal's triangle to do it. So in this case, we have one of those games where you throw the ball and you try to knock down the bottles. Da-da-da. Notice my bottles and my ball being thrown, and this is why I don't teach art. So luckily you got me for math. But okay, so let's say that you're setting it up and everybody gets 4 tries. And let's say it's a 50-50 chance of getting a hit or a miss, right? So you've got this person. They throw it once, they throw it twice, they throw it 3 times. They throw it 4 times. That's a lot of little tree things, and I don't want to have to mess with that, right? Because that's kind of a pain. And let's say you have the prize system that if you knock down 5 bottles, you get a big prize. If you knock down like 4 bottles, you get a medium prize. If you knock down 3, you get a small. If you knock down 0, 1, or 2, you don't get anything. Nothing. Okay, so let's say you want to find out how many of the big prizes you need to buy, or how many of the medium, or how many of the small. So, but we don't want to have to mess with this because this is terrible. There we go. Okay, well, it's really not that dramatically terrible, but okay, we want to use Pascal's triangle because we learned about that, and we want to figure it out. We got 4 tries. Actually, we wouldn't knock down 4, right? 5 if we had, anyway. 1, 2, 3, 4, 5, yeah, okay. I miscounted. Let's see. Da-da-da. So this would be 4, 3, 2. You get the idea. Okay. So let's set up our Pascal's triangle. So when we did that, so this is our start point. Our first try, we have this. Our second try, we always start with a 1. We add these 2 up, we get a 2, 1. Our third try, we get a 1, 3, 3, 1, right? Because remember from before, we add these 2 to make the 1 below it. Our fourth try, we get a 1, 4, 6, 4, 1. And 1, 2, 3, 4. That's all the tries we had, right? We had 4 tries. Let's see. Yes, 4 tries. Okay. So this is our 0. We knocked 0 of them down. This is we knocked 1 down, we knocked 2 down, we knocked 3 down, we knocked 4 down, right? So we can already count for our probability. So this is our 4th time. Our total number, if we add it across, would be 16. So we say, okay, well, our probability of knocking 0 down is a 1 out of 16. Our probability of knocking 1 down, we just read it off the thing, is 4 out of 16. So that's 1/4, right? Our probability of knocking 2 of them down would be 6 out of 16. Our probability of knocking 3 down would be 4 out of 16. And our probability of knocking all 4 of them down would be 1 out of 16. Okay, so I put these because these are getting prizes. Now I want to know how many. Well, first, I need to know how many people are going to be doing this ring toss, this bottle knockdown thing. So I'm going to copy this over. So this is my probability that I found. And that was really fast, but you can go back and watch the video on Pascal's triangle. Okay, so let's say that 50 people are going to play our game. And we already know from before, from the rules that we set up, this is a big prize, this is a medium prize, and this is a small prize. So I want to know how many big prizes I need. So how many? So, okay, big, medium, small, and I'm going to go send somebody to go buy those, right? Okay, so the big prizes, the way I find this is I just go, okay, well, they have a 1 in 16 chance of getting a big prize. I can turn that into a decimal, which, would be easier. And I'm going to multiply that times 50. So if I do that, I go 1 divided by 16 gives me 0.0625. I multiply that times 50. And that gives me 3.125. So what I would do is I would probably buy 4. Or maybe even 5, just in case some people with some skills show up. So that's how many I need to buy. For my medium one, I'm going to need to buy more because the probability is higher. So this one is 4 out of 16, which is 1/4, right? Times 50. So 1/4 times 50 gives me 12.5. So I would probably buy, just to be on the safe side, like 13 or 14. So then the small prize has an even higher probability. The small one is 6 out of 16, right? Yes. I would take that and then multiply it times 50. So basically I'm taking the probability times the number of people total who play, and that gives me the number of prizes I'm going to need. Okay, so 6 divided by 16 times 50, that's going to give me 18.75. So I would probably buy like 20 of them. So those are the number of prizes that we would need. And so those are our final answers. I would need 3.125 big ones, 12.5 medium prizes, and then 18.75 small prizes. So those are my answers. Hooray! So we just used Pascal's triangle to come up with how many prizes we need for our carnival. Yay!